Hello, so today we're looking at the intersection of two planes. So let's have a look at what we're being asked to do. Make it a little bit smaller so we can see the question. All right, so for the system of equations, we're asked to state whether the planes intersect. If they do, state whether it's a plane or line of intersection. And then part B, determine the solution of the system of equations. Okay, so let's have a look at the first one. So it's in green. All right, so our two planes are 3x minus 2y plus z equals 4 and 9x plus 6y minus 3z equals negative 12. Okay, so let's determine whether, well, let's determine if they intersect. That's the first thing, a little bit smaller so we can see what's going on. So we have two planes. Let's rewrite them down here. 3x minus 2y plus z equals 4. And 9x plus 6y minus 3z equals negative 12. So let's label them 1 and 2. All right. Let's do 3 times our first plane or our first equation and see what we get. We get 9x minus 6y plus 3z equals 12. All right, so now we're going to add planes 1 and 3 times plane, we'll add plane 2, these two, and 3 times plane 1. So what do we get? We get 0x plus 0y plus 0z equals 0. So it looks like our planes are the same. So in actual fact, so therefore our planes intersect in a plane since they are the same plane. Okay, so now since we know they intersect in a plane, we want to determine the solution. So why don't we look at the first equation or the first plane? We'll start with this one, 3x minus 2y plus z equals 4. So let's solve for one of the variables in terms of the others. Well, z looks like a nice variable to isolate for. So z equals 4 minus 3x plus 2y. Okay, so now we're going to let each of the remaining two variables equal a parameter. So let's let x equals t and y equal s, where t and s are parameters or values that are real numbers, two different real numbers. So now we have our solution. Oops. Therefore, our solution is, okay, let's start with x equals t, y equals s, and z equals 4 minus 3t plus 2s. So since we have two parameters, t and s, that can be any values, any real numbers, our solution is a plane. So this is a parametric representation of our plane or a solution. Good. Okay, so that's part 1, or linear system 1. So we'll put a 1 there. Now let's look at the second one. Let's do this off to the red one. We'll do it off to the right here. Okay, so let's look at it. Again, let's label our equations 1 and 2, or our planes 1 and 2. Let's do negative 3 times plane 1. That gives us negative 3x minus 3y minus 3z equals negative 3. And of course, we have plane 2, so 3x plus 3y plus 3z equals 2. Now we're going to add these two. We get 0x plus 0y plus 0z equals negative 1, or 0 equals negative 1. Okay, this does not make sense. therefore no solution. Or actually, what do we ask first? Let's answer the question that we're asked first. So no, therefore no, therefore no. Our planes do not intersect. Therefore, there is no solution to the linear system or system of equations. Actually, if we look at our original two planes, we can see that they're actually, the left-hand sides are actually multiples of each other, and the right-hand sides of the equal sign are not. So we actually have two parallel planes. We can draw them. We have one plane here and one right under it. They're both parallel. Good. So in the first situation, we do have a solution to the plane, or they do intersect. They intersect in a single plane, so they're the same plane. In the second situation, we do not have a solution, and the planes do not intersect. They're actually parallel. And well, I think that brings us to the end of our session today. Great. So if you have any questions, send us a note at info@raisebymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you soon.